Welcome to another deep dive. Today we're plunging into Apache Kafka. You know, that foundational tech that's really at the heart of so many modern data systems. We've got some excerpts here from CCAAK exam practice questions and explanations, thanks to a listener. And we're going to use these not just as like exam prep,
Right.
but more as a roadmap, a shortcut maybe, to really grasp the essential Kafka concepts.
Exactly. Yeah, I mean, they're presented as exam questions, sure, but they're actually a fantastic way to look at Kafka's fundamental principles. We'll break down what each key bit does, and maybe more importantly, why it matters, in a real-world data pipeline.
Okay.
The goal is for you to walk away feeling, well, like you really get it.
All right, let's unpack this then. First off, the source gives a tiny bit of context on the CCAAK exam itself, just the basics.
Yeah, just quickly, it mentions typically 40 questions, 90 minutes fixed duration, web-based, remote proctored, multiple choice, multiple response,
Right.
that kind of thing.
Good context. Sets the stage for how these ideas get framed sometimes. Okay, now for the really interesting stuff. We're using these practice questions as our guide. Each one hits a critical Kafka component. So let's start with reliability.
Oh.
Always top of mind, right? You just can't lose data.
Absolutely.
So concept one, replication and high availability. The first question asks, what is the primary purpose of Kafka's replication mechanism? And the answer highlighted is C, to ensure fault tolerance and high availability.
Right. And this is, well, it's just fascinating how fundamental replication is. It really is the bedrock of Kafka's reliability. The source explains it ensures data gets copied across multiple brokers, servers, basically. Kafka calls them replicas.
Yeah, okay.
So think about it. If one broker fails, the data's not gone. It's safe on another replica.
Oh, okay. Fault tolerance.
Exactly. That directly gives you fault tolerance.
Yeah.
And because the data is still there on another machine,
It's highly available. Consumers can just keep reading.
precisely, they can continue accessing messages from the available replicas, no service interruption. It's really a cornerstone for robust data streaming.
Makes total sense.
Yeah.
So you've got these copies floating around for safety and availability. But in a big system like this, with potentially many brokers and many copies, how do you keep track of everything? Who's in charge? Especially deciding which copy is the main one to write to. That brings us to the Kafka controller. Our next question, what is the function of the Kafka controller in a cluster? The answer is C. It manages partition, leadership, and cluster metadata.
Yeah, and if you connect this to that bigger picture, the Kafka controller is kind of like the cluster's manager. Or maybe it's air traffic controller.
I like that.
It's a special broker, right? It gets elected from within the cluster. And its main job is managing who's the leader for each partition. Remember, topics are split into partitions.
All right, the chunks of data.
Exactly. And each partition needs one designated leader broker that handles all the rights. The controller assigns that leadership. And it also tracks other vital cluster metadata, like which broker is holding which replica.
So that keeps everything coordinated.
Absolutely. It ensures every partition has that designated leader for reads and writes, which is just essential for consistent data flow.
Okay, so we have reliable storage through replication and coordination through the controller. Now let's think about the other side, the applications reading the data, the consumers. How does Kafka know where a consumer left off? Like if it crashes and restarts, how does it avoid missing messages or reading them all again?
Good question.
Our third question covers this. In Apache Kafka, what happens when a consumer commits an offset? Correct answer is C. The consumer marks the message as read for future recovery.
Right, offsets. This hits on a really important aspect, reliable processing. When a consumer commits an offset, it's basically sending a message back to Kafka saying, okay, I've successfully processed everything up to this point in this partition.
Like putting a bookmark in a book.
Exactly like a bookmark. The source highlights this is crucial for Kafka, so it knows where that specific consumer needs to resume from if it restarts or recovers. This prevents data loss, ensures messages aren't skipped. It's also key to avoiding duplicate processing where possible. It's fundamental to Kafka's at least once delivery guarantee. Kafka promises it'll deliver the message at least once.
At least once, so maybe more than once.
Potentially, yes. If a consumer processes a message but crashes before committing the offset.
Kafka doesn't know it was processed.
Right. So when the consumer restarts, Kafka will give it that message again, starting from the last committed offset.
Okay, so the responsibility is on the consumer application to handle potential duplicates if that happens.
Precisely. Kafka prioritizes not losing data over potentially delivering it twice.
Got it. Okay, so data's safe, clusters managed, consumers can recover. What about the data format itself? Data structures change over time, right? You add fields, maybe change types. How does Kafka stop that from breaking everything downstream?
Yeah, schema evolution, that's a big one in real systems.
So question 4, which Kafka component is responsible for managing schema versions and enforcing compatibility rules? The answer here is D, Confluent Schema Registry.
Okay, so the Confluent Schema Registry. While technically often used with Kafka, it's not part of Apache Kafka core itself, but it's hugely important in the ecosystem.
Ah, good clarification.
Yeah, and it plays this vital role, like you said, in evolving data pipelines safely. The source explains it manages schemas, often Avro schemas, which are common with Kafka. It stores them, tracks their versions for different topics.
And enforces rules.
And crucially, yes, it enforces compatibility rules. This prevents a producer from suddenly sending data in a format that existing consumers can't understand, or vice versa.
So it stops things from breaking unexpectedly when the data format changes.
Exactly. It allows for safe schema evolution. You can add fields, maybe make some other changes, as long as they follow the compatibility rules set for that topic. Adds a layer of governance and stability.
That sounds incredibly useful. Like almost essential if your data formats aren't static.
It really is, in many production environments.
Okay, final piece of the puzzle for today. Kafka itself is amazing, but it doesn't live in a vacuum. It needs to connect to databases, data warehouses, other apps.
Integration.
How do you get data in and out easily and reliably? That brings us to Kafka Connect. The last question asks, which of the following are valid advantages of using Kafka Connect? Choose 2. The answers are A, enable scalable and fault-tolerant data integration, and D, provides built-in connectors for external systems like databases.
Yeah, Kafka Connect. It's a framework built into Apache Kafka, actually, and it's designed specifically for this job. Scalable, reliable data integration between Kafka and other systems.
So option A, scalable and fault-tolerant integration. That's kind of built in.
Absolutely. The framework itself handles distributing the work, managing failures, scaling up or down. It takes care of those hard parts.
Nice. And option D, the built-in connectors.
Also key. It provides a whole ecosystem of pre-built connectors for common systems. Think JDBC for databases, S3 connectors, Elasticsearch connectors, loads of them. This means you often don't need to write custom code for integration. You just configure an existing connector.
Wow, that must save a huge amount of development effort.
Oh, definitely. It makes connecting Kafka to the rest of your world much, much faster and more standardized. So maybe something for you to think about is, how do these 5 mechanisms, replication, controller, offset, schemas, connect, all depend on each other? How do they interact to create the complete, robust platform that Kafka is?
That's a great point. It's the synergy between them. Thank you for joining us on this deep dive. We hope this exploration has given you plenty to chew on and maybe some new insights into Kafka.